Hi there and welcome to Physical Sciences for Year 10. In this video we're going to be comparing displacement versus time graphs. Okay, so as we've learned so far, displacement is a vector and displacement basically stands for the distance that you travel and the direction that you happen to be going. Now this can be placed in a graph over time, and from this you should be able to interpret exactly what's going on with respect to a journey. Okay, now in order to work out distance, that's easy. The higher up you go on a distance time graph, the more distance you've travelled. However, you know now that if you look at the graph below, where the x-axis is, we've got two sections. We've got the area above the line, we're going to call that positive, and the area below the line, we call that negative. So if the line is approaching, going away from home, which is the x-axis, in a positive direction, i.e. going above the line, we say it's going in front of home. If it's below the line, then we say we're behind home. So using positive and negative notation allows us to understand how far in front or behind home we happen to be. So to recap, if we've got a positive value, then we're in front of home, and if we've got a negative value, we're behind home. So now we can actually interpret where we stand in relation to where we started with respect to using that positive and negative notation. The higher up we happen to be going on the y-axis will tell us the distance that we happen to be in front or behind of home. The segment that we're in will tell us whether we're behind or front of home. So let's just have a look at the diagram, explain the diagram. So you can see we've got home on the bottom horizontal line, which is our x-axis. The x-axis will also code for our timeline. Okay, now you can see the blue line, in this case, has a displacement of 5 meters in front of home. Now, let's interpret that. 5 meters, well, if we look at the top of the blue line, it finishes at the 5 meters, and we read across on the y-axis and we can see it's 5 meters away from home. It's in the positive section, i.e. it's above the timeline or the x-axis, which means it's in front of home. Now let's have a look at the green line. Well, the green line goes exactly the same distance, but its displacement is different to the blue line. Why is that? Well, the green line finishes in the negative segment or below the x-axis line. This means it's behind home. So, blue line shows us that we're 5 meters in front of home. The green line shows us that we're 5 meters behind home. So hopefully you can see that obviously, depending where the line is, it's going to give us a different piece of information, and we will be starting or finishing at a different place if we use the blue line or the green line, even though the distances that we travel is the same. Now, the total distance that you might travel in a journey, we have to just add up all the values as to how far we went in each segment of the line, and we'll cross that bridge later on. Okay, now another important thing to understand from a graph, especially when we're dealing with a distance time or displacement time graph, is the gradient. Now the gradient is how steep a line is. The steeper the line is, the higher the gradient. The flatter the line is, the shallower the gradient. Now on a distance time graph, the gradient can be calculated by the rise, which is the vertical distance you go, along the run, which is the horizontal distance that you go. So to measure the gradient, what we need to do is to say, find our line, find the highest point that that line goes to, and measure the distance, the vertical distance, from the x-axis to the top of our gradient line. That's our rise. Then we need to work out how far along did it go. That's our run, up to that point. And then we divide our rise over our run. And on a distance time graph, the rise over run, or distance over time, we classify as our speed. So you can see on the graph here, the dark blue line is our gradient. And you can see that it's made up of the rise, which is the vertical distance, divided by the run, which is the horizontal distance. We divide the rise by the run, and that will give us the speed. Now, other things that we can interpret from this graph. If the line is a straight line, then we say that the speed is constant. because the gradient is constant. It never changes. If the gradient is getting steeper, then we can say the velocity or the speed is steeper. Now remember, velocity is speed plus direction. So we can state that if it's above the line, it's a positive speed. If it's below the line, it's a negative speed, or a positive velocity or a negative velocity. The steepness of the gradient will determine how fast it is. Obviously, if the gradient is shallower as we get lower down or closer to the x-axis, the result is that the speed or the velocity has become slower. And obviously, if the gradient is above the line, it's a positive velocity, and if it's below the line, it's a negative velocity. If the line is changing or curving, okay, now it can either be curving in this direction or it can be curving in this direction, then we state the velocity is changing. And we'll come on to that later, but just to let you know, if the velocity is changing over time, that is called acceleration. So we are saying that instead of staying constant, i.e. the speed doesn't change, it's now accelerating or decelerating depending on which way the curve goes. Now, as I said to you, the direction of the line is going to tell us the direction that the object happens to be going. And just to reiterate, if the line is going into the positive section of the graph or above the x-axis, then we're stating it's in front of home, and if it's below the x-axis, i.e. in the negative section, we say it's behind home. Okay, so let's have a look at some exercises. So I've got 3 graphs here. Now, on the graph, we can see that the vertical axis has been given the symbol S. Now, S stands for distance, and that's the y-axis. Along the x-axis, we've got the symbol T, that is time. Now, the x-axis will also tell us home. It's our position from home. Now, we always start, in this case, we can start at home, or we can start a distance away from home. And we'll look at each graph in turn and see how it works. Now, if we look at the first graph, the top graph, we can see we start at 0, 0. That means at time 0, we're starting at home. Now, what do? Well, we can see that in the first segment, if we split the graph up into 3 sections, the line going upwards, the line getting steeper, means we're moving away from home. Now, because we're going into the positive section, it means we are going in front of home. Now, the line is straight, which means it's a constant speed. So we travel at a constant speed in front of home, and then the line goes horizontal. Now, if it's horizontal, it means that the distance doesn't change over time. Well, in order for us to not change distance over time, we need to stop. So we went to the constant speed for a certain distance and a certain time, then we stopped, and then we went to the constant speed again and ended up a certain distance away or in front of home. So constant speed, then we stopped, constant speed, and we ended up a certain distance at home. Now, to work out the total distance that we travelled, all we have to do is add up how far we went in each section. So in the first section, we did a certain distance. In the second section, which is flat, we did no distance at all. And in the third section, we did another distance. So if we add the first and the second distances together, we'll get the total distance travelled. So overall, the object moved in front of home, then stopped for a bit, and then moved further away, noting that they're at constant speed. So let's look at graph 2. In graph 2, at time 0, we started. Now, if we look at it, the line starts a long distance away from home. So we started away from home. Then what did we do? Well, we travelled towards home. Now, the line is nice and straight, which means it's constant. So we travelled a certain distance at a constant speed, and then we stopped for a period of time. That's why the line is flat. Then we travelled back to home at a constant speed again. So we started a certain distance from home, we travelled at a constant speed for a certain amount of time, then we stopped, time carried on, but the distance didn't travel, and then we carried back on at a certain speed, and then we finished off at a certain time at home, and finished bang at home. Now we can calculate the speed for each section by doing the rise over the run. So to recap, The object started some distance in front of home, moved back towards home, rested for a time not moving, and then travelled back to home. Okay, now let's look at our final one, which is number 3. Now, number 3, we start at home at time 0. We travelled a certain distance over time. The line is straight, which means basically it's a constant speed. So we travelled a certain distance at a constant speed up to a certain point, and then we stopped. Now, then the line goes back on itself. So it travels in a straight line, and as it travels in a straight line, it means it's a constant speed. So we travelled in a straight line at a constant speed, but in this time we went back to home. But we didn't stop at home, we carried on behind home. So it's like going up to a certain point, remembering, let's say you've forgotten something, you go back home, you get that thing, but you don't stay there, and you carry on in the opposite direction. Notice that the speed above and below the line for that last section is exactly the same. So, to recap, this means that the object moved in front of home at a constant speed, then stopped, and then moved back to home, again at a constant speed, passed straight past home, and went in the opposite direction a certain distance. Okay, well, I hope that's been useful to you. What I'd like you to do now is have a look at these exercises, exercise 1.2 and 1.3 from chapter 3 of your iBook, and check out the answers and see how you go. Thank you for watching.